All right, so let's just review real quick before I get you out of your seat. We got this group of students, bag of candies, the proportion that are blue in there. And the company claims, you guys can read it, that 24% are blue. So we did a simulation of 100 times, 50 candies in each bag, and see how many were blue. And just like we did yesterday, we plotted them. How many were blue? 10%, 20, 30%, 40%. We found that the mean was 0.254. That's 25% as a decimal. Standard deviation was 0.060. Can you guys come up with an interval that contains the middle 95% of this data? What's another way of me asking this? What am I asking everyone to find here if I'm asking for an interval that contains 95% of the data? Oh boy. What have we been talking about? The interval that contains, or 95% sure contains the mean. The confidence interval, correct. And by now, if we don't know how to find confidence interval after what, 2 days of finding it, I'm sorry. Not really. I'm sad for you. What's the first thing I need to find?
Margin of error.
Margin of error. All right, here we go. Time to hear from individuals. How do I find margin of error? Oh, 18, margin of error.
Plus or minus 2 times the standard.
And usually, where can I get the standard deviation? This problem gives it to me right in the problem. Sometimes, though, remember, it's right up there in the box. All right? But they give it to me here, which is 0.060. So your margin of error, please don't forget the plus or minus part on the test on Thursday. So your margin of error is going to be 0.12. Any issues? All right, that leads to my confidence interval, abbreviated CI. And how do you find your confidence interval now? Oh, 10, confidence interval. Yeah, we're going to have some, I figured this. 18 again, confidence interval.
The mean plus or minus the mean.
Yep, so I go the mean, got it from the table, 0.254. Plus or minus my margin of error I just found, 0.12. Got it. Make sure we add and subtract it. And then hopefully that confidence interval is listed as a multiple choice. I believe it is. And again, what's this telling us? This is our percent as a decimal. Whatever these candies are, on average, we're pretty confident that we're going to find between 13% and 37% of them are blue. That's what it's telling us. Okay. We're pretty confident that I open up one of these bags, 13 to 37% of them are going to be blue. Questions, comments, going. All right, let's roll. Next one, still doing some candies. The old J&B company. It says 45% of its candies are blue. Yep, some are brown, yellow, perfect. So we're going to take a sample of 65 200 times. More samples, the better. And the results down there are shown. Oh, Big Bonnie comes by, purchases a bag of the old J&B candy, and she counts 24 blue candies. What can we conclude here about her 24 blue candies based on my simulation here? Her 24 blue candies. Is it a rarity? Or is it right where it should be in the old, we can really rule out number 1. That's never going to be an option, sorry. Or 3. We're really saying, is it a rarity or is it right where it should be? How can we check? I guess you could argue with me that you could just look at the dot plot and see where 24 is and say if it's in the middle or the edge, but I don't know. I'm a little concerned about that one. I don't know if really I'm confident enough to say it's in the middle or not. Oh, let's find the confidence interval because I have the mean and the standard deviation there. All right. Here we go. Margin of error first. I'll ask it again. Ask it again. Oh, 1. Maddie, how do I find margin of error?
It's plus or minus 2 times the standard.
Which is what in this case?
3.936.
Yep. Oh, people are going to freak out today when I don't give you that little box on the dot plot, and we got to figure it out anyway. Oh, boy.
Wait, what?
The little mean and standard deviation there. What happens if that's not given to you today? Oh, boy. Panic. Confidence interval again. Give me actual numbers here. 14 actual numbers for the confidence interval here. What do I have to add? No, just tell me what I need. Just set it up. Don't tell me what it actually is.
So like the mean.
Yep.
So 29.270.
Plus or minus.
Plus or minus 7.872.
Thank you. All right, so we'll be pretty confident that how many blue candies should be in every bag here? About 21.398, so about 21 blue candies all the way to about 37. So what can we say about Bonnie's bag of candies? It's within the middle 94%, supporting the company's claim. Yep. So good try, Bonnie. Back yourself up.
What is the 95% have to do with that?
What's that?
What is that 95%?
That's just the percent that statisticians chose to, that we're confident that the mean's in between here.
Okay.
Yep. All right, questions? All right, I'm going to bounce around here today. That was just a little review. Bounce around here today. I'm not going to go in order. I'm going to start with problem number 5. Problem number 5. All right, kids, in front of your desk, you have this little lever that some of you realized earlier in the year. That if you press it, your desk come up and it becomes a standing desk. So why don't you stand up with your desk and bring yourself to the front. Ryan, slide your desk over this way towards this group. You guys make sure you're on that side of the room for me. Lizzie, slide your desk on that side. I want 2 separate groups here. 8 separate groups for me.
Am I going this way too?
Yes, get over there.
Oh, sure. This is a competition. I know. Are we playing different?
No.
No. Am I not going to the other side?
This is
We're playing different. Who's in the group? Everyone's so far. What the hell is this?
Okay, here we go. With today's topic. Here's what we're going to run a controlled experiment.
okay.
This group over here is going to get scented paper. And this group over here is getting unscented paper. And I want to see if the paper improves your memory or not.
Okay.
All right? So you get the paper. We have a memory test. Each person gets the same exact test. I correct it. I do the average for each group. And what happens? You guys that got the scented paper, you averaged 23 on the memory test. Congratulations. You averaged 23. You guys with the unscented, averaged 18. Here's my question, though. Did you guys do better because you had the scented paper?
I don't know.
Maybe. Well, just by test scores you did. But what other factors could have came into play here that these guys did better than maybe other than the scented paper?
Oh, study.
Maybe this group had better memory.
Yeah.
I just put together these group of 7 and they just happen to have better memory. Maybe they're better test takers.
Correlation, not
You have to do it more
causation.
times.
Everyone see that maybe it wasn't because of the unscented paper.
Yes.
But this is what we're going to test today. If it was or not. Was it because you guys did better because of the unscented paper or the scented paper? Or heck, it was just by random chance. I just happened to put the 7 together and I got a better score than you 7. That's what we're going to test today. Was it because of the scented paper or just by random chance? Okay? So the first thing we need to find every time is the difference in the means. What was their difference in the means right now? So that's an easy calculation to do. I'm just going to take the mean from one group, the scented group, minus the unscented group. And that would be
5
23 minus 18 equals 5. So there's my difference in the means is 5. Which means what? What's that number 5 mean in this type of problem here? And this, what's that number 5 mean in relation to this problem? The people that had the scented paper did 5 points high, on average, 5 points higher than the unscented paper people. All right, so here's what we're going to do. You guys know from this unit, 1 doesn't cut it, right? We need more and more and more samples. So here's what I'm going to do. Here's what I'm going to do right now. Sarah, move over. Yep, just take your stuff. No, just take your stuff. Switch with Logan. Tomer, switch with your boy back there. I'm going to reshuffle the deck. I'm going to reshuffle the deck and see what the averages come out to be. All right, so everyone has a test score. I just reshuffled the deck, found a new average over here, found the new average over here, subtracted them, and then I plotted wherever it happened to be. So say it was, now the average is 2 off. Now I plotted 2. Ava, come on over, switch with Emily. Sarah, go on back.
Oh my God.
Libby, switch with Sarah. No, Logan, you stay there. I didn't tell you to move, boss. You stay right there. Switch. Now I got a new group. Random groups, right? Random groups. I calculate the average over here, calculate the average over here, subtract them, plot a new point somewhere. I'm going to keep doing this 1,000 times. And here's what I want to know. These new groups I'm making are all by random chance, correct? Where does the 5 fall in to these new groups of random chance? Is it a significant number or is it right in the numbers from random chance groups? That's what we need to test right now. Where does this 5 fall? Is it by random chance or is it really an unusual number no matter how I made the groups? That's what we need to test right now. And how are we going to test it? Does it fall within the confidence interval or not? Where does 5 fall? Inside or outside? So let's test that right now. Does 5 fall inside or outside our confidence interval? So, you guys have values to find these? Plus or minus 2 times. What are we going to multiply the 2 by here? Oh, 17.
Plus or minus 1.54.
Good. 1.548. That'll be plus or minus. What do we got there? 3.096. Go ahead, find your confidence interval now. What number am I going to add and subtract with the margin of error now? What number up here? 8. What number up here am I going to add and subtract to 3.096?
You are going to be 0.03.
Good deal. And it says keep reading. Make sure you guys always read the directions here. I do have to round to the nearest hundredth.
Can you do it at the end?
Right here, yeah, I would prefer you do it at the end. Don't round in the middle because that may throw off your final answer. So we're getting negative 3.01. We all good there? No, sorry, 0.7. Somebody should have caught me on that, huh? 3.07. All the way to, and by the way, if you're wondering, how can you get a negative? That just means the unscented people did better than the scented. Because remember how we're finding these numbers? We're doing group 1, the scented minus the unscented. So if you have a negative number, all that means is up in one particular group of random people, the unscented people did better than the scented. Libby, yes.
So the mean goes before that MOE.
It's mean plus or minus your margin of error.
Oh,
Mean plus or minus your margin of error. And then over here we get what? 3.1, 3.1. The 6 rounds the 2 to a 3. All right, so where did the 5 fall?
Outside of it.
Inside or outside? Outside. All right, outside. So what's that telling us here? The 5 is rare. It's significant because we never really got too many 5s just by randomly putting them together. All right, so what do we say about this here? Guess why you guys did better? Not by random chance. Because all these values in here were by random chance. Look where my poor 5 was on the outside. So you guys did better because of the scented paper. Meaning that 5 is statistically significant. If it falls outside, let me say this, and I'm going to say it over and over again because it gets confusing, I know. If the number falls outside your interval, outside, it is significant. It was not by random chance that it happened. So therefore, it's significant. So is the difference significant? Yes. And explain. Because what was my value I was testing between the two of you guys? What was the difference in the means? Because 5 falls outside the confidence interval. And again, it's significant because everything in the middle, guys, everything in the middle is just happening by random chance. Me just going, you over here, you over here, you over here. What's the new averages? All right. And none of those came close to 5, as you can see by the simulation there. So it is significant. It's unusual that we got a 5. So it must be because your scented paper worked. Questions? One doesn't make us great here, and I got even more of a challenge for you on this next one. Ready? Anything you want to ask? All right, go backwards, number 4. All right, instead of scented paper now, I'm going to give you guys some tutors. All right? Group 1, you guys actually meet with a human being twice a week for 1 hour. You guys over here, you're doing it all online. Okay, I'll give you a little online tutorial. All right, and we'll see who's got the better test score. So what happened? Group 1, your test score came out to be what? 80.16. Congratulations, 80.16. Yeah. Highest grade so far for some of you. Moving on. Too harsh? Sorry. 83.8. So is it safe to look? This group, the online people, did better. Was it because of the tutoring though?
I don't know.
What other factors could be involved?
Smart.
I just got the smartest 7 out of the whole class.
Yeah.
Is that what you're telling me? Okay.
Why
better
would you
tell
be
that to
getting a
those guys.
tutor if you're like the smartest?
So let's figure it out. Or cheating. Good.
It's
Good. How about
72
instead of saying cheating, good eyesight? Better eyesight in this group than over here. Okay. Yeah. Resources. Yeah. So let's figure out if it was because of the online or not. Okay. Let's figure it out. First thing we need to do is, because remember, your simulation here is always based off the difference of these two means. So that's the first thing we got to find. And usually the problem will tell you to, which it does, calculate the mean difference. And we're going to do that using group 1 minus group 2. All right, ready? Group 1 minus group 2. And they should tell you what order to do it in.
wait, so you don't do the highest number?
No, because it's also based off of how they do this, the simulation. So they're doing it for group 1 minus group 2. So the mean difference, however you want to explain it here, I got what? 80.16 minus 83.8.
Yeah. Negative 3.
Yep, and it's okay to get a negative. We'll talk about what it means. What do you got? Negative
3.64.
3.64. All right, and I am going to ask this. So will the regents next month? What's that mean, that number, as far as this problem goes? Negative 3.64. What's that telling us?
Group 1 lost 3 points.
Say that. Go ahead, Maddie. Try to get something out there.
Group 1 lost 3.64 points on average.
Okay, good. I like it. On average.
To Group 2.
On average, Group 1 scored.
3.64 points less.
There you go. 3.64 points lower than Group 2. Or I could, I could put that in reverse and say what? Group 2 scored
3.64 points higher.
higher. Yeah, that's fine too. All right. So on average, Group 1 scored 3.64 points lower than Group 1. I will ask that. The regents will ask, what the heck does that number mean you just found? You just got a point for subtracting it. Now, what's it mean? All right. So was the online tutoring was the higher grade because of your online tutoring? You ready to find out? So I got to figure out if negative 3.64 fits where? Within. If it does fit within, it was by random chance. If it fits outside, it was significant. It was probably because of the online tutoring. Uh-oh. Problem.
Oh, you're not given the thing.
Oh boy, how are we going to calculate the interval with no numbers?
Yes.
So sad. So sad.
Like doing.
Here's how we're going to do it.
I know.
And you don't need to copy this part down. Remember our good old curve?
Oh, yeah.
All right. When we do a confidence interval, what percentage does it represent?
100.
When we do a confidence interval, it's 95. All right. So I know 95% are going to be by random chance in here, meaning what percent's left over? 5, right? 5%. But I got to go equally on both sides there. So how much percent do I have on both sides?
2.5.
All right, so 2.5. So if any score falls outside within this 2.5% range, it's going to be significant. Well, wrong one. Where's negative 0.364 fall? Look at our graph. Can you kind of see where negative 3.64 will be?
Yeah.
This is negative 3 right here. So what are we thinking? Right here, these two?
Yeah. Something like that.
Right about there?
Yeah.
Here? Right? Negative 3.64, right about there. All right, can you guys add up the number of scores that are below that? About. Let's just, we'll be in the ballpark. I'm not looking for exact here, but what do you think? How many scores? How many of these scores here?
Like 9?
9? What do you think?
Oh, yeah. 9. No. Yeah. Yeah. Probably like 9. 8.
8, 9. That's fine. It doesn't matter which one we use, as long as you guys don't say like 50.
Okay.
But everyone in agreement about 8 scores here? I will go with 8. Is that all right?
Oh, yeah.
8? All right. Well, it's 8 out of how many times we do this? Let's go back, read the problem. How many times did we shuffle the deck here? 100. 500 times, right? So these are 8 scores out of 500. What percent is that? 8 scores out of 100 or 500.
0.016.
0.016, which is what percent? About 1.6%. So I don't need a confidence interval. What is that telling me right now? Where's the negative 3.64? Outside, right? So is it significant or no if it's outside? It is significant. It's not by random chance, because if it was by random chance, it'd be on the inside of our 95%. All right? So what can we say about you guys that got a higher average? Why?
Because of the online tutor.
Because of the online tutoring, correct. Most likely. Yep. So is there a significant difference in final grades? Yes. negative 3.64 falls outside the confidence interval. Or you could say the number of scores is less than 2.5%. That's another way of saying it. Molly, you had that look on your face. Go ahead.
Oh, I don't know. I was just confused, like the percent. Like, how do you know that the negative 3.64 falls outside?
Because there's only 1.6% of the scores are below that point.
So it would have to be over 95% for it to fall within it.
No. It would have to be above 2.5%.
Oh, because that's the outside.
Yep.
Okay.
And think, I've never done this because I just don't want to make more confusion. But look familiar,
Yeah.
Oh
all right? These are looking like our curves that we dealt with. All right, and yeah, there's about 95% right in here.
So if it's
Okay.
above 2.5, it's within, and if it's below, it's
Correct.
okay.
And hopefully, cross your fingers, it never comes out to be 2.5 because I don't know the answer to that. All right. I don't think it ever would. Yes, Libby.
Oh yeah, I was just gonna clarify that too.
Yeah. Other questions? Do you think listening to a certain type of music affects your test scores?
Yeah.
Let's see on number 6.
Okay. Let's see.
Why are you sitting?
My back hurts.
Ava,
My ears
if you're
hurt.
gonna sit like this.
That looks so much like I'm gonna fall
All right,
and break
great stories. Here we go. So I'm going to put half the class is going to listen to classical, half the class is going to listen to rap while they study, and we're going to compare your quiz scores again. So classical group, there were your quiz scores. Rap group, there's your quiz scores. John said he rounded the difference of the means as 7. How did he get that value?
He
I don't care. Sure. He said the difference of the means was 7. How did he get it? Basically, I'm asking you. You guys help me. Can you help me calculate the difference of the means so we can show why it's 7?
yes.
Kim, how do I calculate? Usually I just subtracted 2 numbers, but I don't have those numbers now. Got a
Find the
suggestion how I
mean.
can find those 2 numbers?
Find the mean.
All right, here we go. So let's find first the mean of classical. I don't know, but I'll just tell you, first period didn't say a word. Tough. Unlike some softies I got in here right now, but it's fine.
Say a word. No word.
About standing the entire time.
No one
Yeah.
wants to
Didn't say a
stand
word.
and do math.
Just saying. Just putting that fire under you. Not that you
I
care.
gotta go to work soon. I don't want to stand right now. I'm about to stand all the time there. 1, 2, 3, 4, 5, 6, 82.
So the mean score for classical should have been 82. And again, if you're wondering, how are they getting these numbers? We have a list, and we have one of our stats.
No, I didn't do it like that.
$82, and then for rap, 25. So how did he get 7?
So, he did it.
What did he do?
He rounded.
He did 82 minus 74.625 and got about, rounded it and got 7. So that's how he got his 7. So that's the first part of this problem. Second part is, and what does it represent? Okay, so here we go. Third time talking this through today. What's the 7 represent?
7 points higher.
On average. Make sure you say on, because that's not a given that everybody did 7 points higher, right? On average. Yep, on average, classical scored.
7 points.
Yep. Well, was it because they listened to classical?
Let's see.
Well, yeah, let's find out, right? So where does the
My
7?
guess is no.
Where does the 7 fall? Everyone sees where 7 is?
5, 6, 7.
Yep, right here, 7. Well, I think we know the answer just by looking, right? But I can't say because the graph looks like it. We got to mathematically determine if it's significant or not. All right, so how many are at or above 7?
3. Wait, sorry guys. I don't know. I'm looking at the dots.
Wait, yeah, I'm confused. What do you mean by that? Like with the other one too, I didn't.
At or on the outside of 7?
Oh, 4.
4, right? Sorry.
I was
On the
basically
at or above 7? 4, correct? Out of,
200.
reread it. How many dots do I have here? 250. So 4 out of 250.
That does not look like
About what percent here? 1 point.
that. We keep doing the same thing.
1.6%. Significant number? That's 7? Significant or no? By random or not by random chance? It is significant, correct, because it falls outside our 2.5% window. Are we okay on that? I know, now look, I probably did a poor job. I've chosen 3 in a row that are significant, but the last one might not be significant, so. All right. Yep.
Sorry. So how does finding the 1.6% help you determine that it's like in the 2.5?
Because,
Because it's in the 2.5.
correct, right? Here's 95%. Here's 2.5% and below.
Oh, okay. So it's like an okay.
Correct? Basically, what I'm trying to do here, Libby, is hey, the more and more I do, look, the more and more I do, this is going to resemble our curve, right? And I got to figure out where's that 7 would hit. And it's going to hit not in the 95, in between the 95s.
Okay, so if it was like 76%, then it would be
Correct.
significant.
It's not significant. It happened by random chance. All right? So here you go. Let's answer our question here. So yes, 7 falls within our confidence interval. Or less, or 7, 1.6% of the scores are below 7. That's fine too. 7 falls within our confidence interval.
Do we have to write that on Thursday?
And on the regions. If I had to put money down on a specific question being on there, it's going to be one of these. That'll be worth 3 or 4 points for you. And this should be free 3 or 4 points. Hi, Molly.
Hi. So it's within. It's not.
See?
Sorry, I just was confused.
Yeah, I know. I keep thinking about this next one coming up, but it's not an excuse. 7 falls outside the confidence interval. Thank you, Molly.
Yeah, anytime.
All right, so far everything's been falling outside, and that means our it's significant. So what's it look like when it doesn't fall outside? So let's go back to our Gabriel question number 3, the only one we haven't done today. Little multiple choice question.
So you say it's gonna be on our regions. It's also gonna be on our test, right, on Thursday?
Yeah.
Oh yeah, yep. There's 2 of these questions on there.
Okay.
I'll let you know right now. 2 of the questions are going to be just like this. Find the difference in the means. Look at a graph. Is it significant or not?
Plastic.
Yeah. How about we're going some maters here, huh? Yep. We put 13 of them in black plastic mulch, and 13 of them without mulch.
Wait, why is the mulch made out of plastic? Yeah, what is plastic?
I don't know. I don't know what it is. Sorry, I'm not the gardener here.
I feel like you should take up gardening.
Yeah. Yep. I can see that.
Right after yo-yoing.
Yep. Right after yo-yoing. Yep.
Add that to the list.
Yep. Let me ask my constituents about it, and I'll get back to you. All right.
Okay, plastic mulch.
Yep. And what did we find out? The ones in plastic mulch grew
5 ounces greater.
5 ounces
than the
greater.
plants without.
So what they're telling you, you don't even have to calculate it here. I'm telling you that the difference in the means was 5 ounces. Right? Difference in 5 ounces. So was it really because of the black plastic mulch or some by random chance, some other factor? So we did it 100 more times. shuffled the deck 100 more times, did the difference in the means, and this is what we got. Where's 5?
In the middle.
Everyone see where would 5 be here? Right about right here. Now we could count and do it out of 100, but since this is multiple choice here, is it going to be on the edge here? Do you think near our 2.5% at all?
No.
What do you think?
It's in the middle.
Yeah, it's in the middle. So probably it happened by
Random
chance, not because I gave it black plastic mulch. All right, so we go look through the choices here. Choice 1 said there was no effect. Well, baloney, because they told me one was 5. They told me it was 5 ounces greater, so that can't be it. There definitely was. But 2 says there was an effect, but it's due to random assignment. All right, not because it was in the black mulch. All right, questions? Inside versus out. Outside, it's significant. We'll do more of them tomorrow during the review. Congratulations, everybody, for completing the Algebra 2 curriculum.
Wait, we actually did?
I got nothing new to teach you anymore. Review for the test, review for the regents. Put your desk back in the groups for me. Good work today. Pre-calculus.
Is it gonna be harder than this?
Ow! Oh my god, I'm sorry.
Molly, I can't even describe. Like, you have to go through the second half of this course. Like, I teach one day. The next day is practicing with your groups and showing your work, so I can give you credit. And then the occasional quiz and test.
I couldn't do too bad. Why are you moving your chair?